In Chapter 6, we begin our discussion of alternating current. Generation of alternating current. A voltage supplied by a battery or another DC source has a certain polarity and remains constant. And we looked at that in our discussion of DC. And then we had we looked at a battery connected to something, and we saw that it had a positive polarity and a negative polarity, and it remained constant. It did not change. Alternating current AC varies in polarity and amplitude. And so here we see an AC sine wave, and you see that it is constantly changing, going negative or going positive and then negative, and it is alternating. AC is an important part of electrical and electronic systems. Systems that use alternating current include 120 volts out of the wall, and sometimes this is referred to as 60 cycles because it alternates 60 times a second. And during the positive cycle, current is flowing one direction, and during the negative cycle, it is flowing in the opposite direction. Radio waves for television and radio transmission use alternating current. Microwave transmission, Ethernet, all of these are examples of alternating current. Your text starts the alternating current discussion with a very simple circuit that could generate AC. By moving the switch back and forth, the output would be an alternating positive and negative value. And the switch would be right here, and this would be our load. And this switch would be switched between this point and this point. I think your text does this because we have looked at DC, and this would be a way of generating an alternating current source. It'd be far from ideal, but we could do it this way. And by looking at this, we get a sense of the movement of current. So let's take a look at this first, and if the switch is in this position, notice we're connected to the positive battery. Remember, current is flowing from negative to positive, so from the negative side of this battery, we would come down through the ground. Remember that from ground to ground, that's the same electrical point. So coming from the negative side, we would come down, and our flow would be up through the resistor to the positive side of the battery. So this would be our direction of current flow, and the current would be coming up through the resistor to the positive side of this battery, and that would give us the positive side of this wave shape. Now, when we pull the switch down and now we have it connected to this point here, across here, notice now we're connected to a battery, but we're connected to the negative side, and so current is going to flow again through here. It's going to come through here. Now it's going to go across the switch because it's pulled down now. It's going to go down the resistor, and then it's a little bit confusing. It looks like a figure 8, but this would be the path for current. Now the difference here is that now notice the current is flowing down through the resistor rather than up. And in this particular configuration, that is where we're going to be generating the negative part of this square wave. So point being that when you have the positive part of a alternating wave, the current is going one direction, and when you have the negative, it is going the opposite direction. So current is constantly changing direction in alternating current, and by its very name, alternating current gives you the sense that current is changing direction. And if we're thinking about 60 cycles household current, that current is changing directions 60 times per second. Alternating currents are repetitious and consist of a continuous series of cycles. And here we have an example, continuous series of cycles. The time for one complete cycle is called the period of the waveform. And so here we have one complete cycle, and that is referred to as a period. A period consists of two opposite polarity alternations. So here we have one going negative, one going positive. and that makes up one complete period. If the positive and negative waveforms are equal, it is symmetrical. And we're talking about alternating current AC out of the wall. It is a symmetrical. If not, it is asymmetrical. The rectangular signal above is a digital signal. The abrupt changes in polarity are necessary for digital circuits. Okay, sine wave characteristics. The basis for an AC alternator or generator is a loop of wire rotated in a magnetic field. And so here we have a coil of wire that is rotating, and it's very important to remember that it is rotating. It is connected through a shaft, and there are slip rings and bushing or brushes that will be the contact point for taking the voltage off of this coil. And you'll see here the relative movement of that coil. You see the north and the south pole magnets, and you see this coil of wire that is being turned, and in the process of turning, we are generating an AC signal. Now we could go over, let me just go over to this link right here. This particular site called Molecular Expressions, they have a lot of neat simulation. This is a Java simulation. By the way, if you go to this, you'll have to have Java on your machine. You may have to install that if you go to this particular link. Okay, let's take a look at what's going on here. Here we have an AC generator. You'll notice that the coil of wire is turning inside the magnetic field. You'll notice here are the slip rings, and they are turning. You'll notice the brushes are connected to the slip rings, and one end of this coil is connected to one side of this ring, and the other side of the coil is connected to this ring. And the differences of potential between these 2 points is what we're seeing on the meter. And so you see this is measuring voltage, and you notice that the voltage is swinging from positive to negative and back and forth. You also see the sine wave that would be generating, and you can see that it is alternating positive to negative, and we have our characteristic sine wave here. If we were to increase the frequency here, increase the speed of the coil, you'll notice that the faster that this coil turns, the larger is the sine wave. And it isn't just that the frequency increases, actually the amplitude, the actual voltage is increasing. And so if I crank this way up, you can see that this is getting near, it's almost pegging the meter going both directions. And that's a principle of AC generation, that the coil must be moving in the magnetic field to generate a voltage, and the faster that it moves, the larger the voltage it will be generating. This is because the coil is cutting more magnetic flux lines. Okay, so here we just took a look at an example of the slip rings and the brushes, and we saw the turning of the coil in the magnetic field. And let's see, this is just repetitions from what we just looked at there. It's the loop of wire. This is just a little bit bigger picture. Slip rings, bushings. As the conductor and coil rotate, waveforms are generated. Okay, the magnitude and polarity of the generated voltage will be shown in the next slide. Okay, here we have a little more detailed analysis of what is going on. Here we have the rotating coil. At 0 degrees below, note the conductors are parallel with the flux lines and no voltage is generated. So here we see the coil is parallel with our north and south poles, and we're at 0 degrees. At 90 degrees, the conductor is cutting a maximum number of flux lines and generates voltage B. So you see, let's remember the blue side of this coil and the black side. The blue is over here toward the north side, and we are at 90 degrees. We're generating sine wave B. At 180, or excuse me, at 180 degrees, we're at the same situation we were at 0. Okay, so notice again, the coil is parallel again, and we're at 180, but we're at 0 volts. At 270, the conductor is again cutting the max number of flux lines, except the polarity has shifted, and the voltage is now negative. So here, notice we look kind of like this, except notice that the blue is over here in the south, and over here it was north, and now we are generating our negative signal, and we are at 270 degrees. At 360 degrees, right here, we return to 0 degrees, and a new cycle starts again. If we were generating AC for home use, this cycle represents 60 times, would repeat 60 times per second. And here we have some sine wave characteristics. The sine wave at the right consists of 2 opposite polarity alternations. So here we go. Here's one polarity, positive polarity, and then here is the negative polarity alternation. Each alternation is called a half cycle. Okay, this is half and half. So here is one complete cycle. So obviously this is positive, that's half, negative, this is half. Each half cycle has a maximum value called the peak value. And so you'll notice here from this is the flat line in the middle, it represents 0 volts. So we have a peak value from 0 to this peak, and from the negative going from here to here. Now I have a simulation with electronics workbench. Let's take a quick look at it. Here we have a 1 volt 60 hertz signal. I've got an oscilloscope connected to it, and we see the sine wave. If I activate this, let's see if we can make it go. Okay, here we go. And we see the sine wave being generated, and we're measuring it on the oscilloscope. Great. Okay, ignore that. That was a computer glitch. Didn't expect that to happen. Okay, all right, let's continue. Here we have our 1 volt 60 hertz signal being generated, and we're looking at it here on the oscilloscope. And if we were to, why don't we pause this, and let's take a little bit closer look. If we go to, let's see, let's go to this point right here, and then we'll move this point over to right here so that we're looking at one cycle. And down here we see the time between the 2 points, between 1 and 2. You'll notice it is 16.7. In fact, it probably should be 16.6 milliseconds, because that would, well, we have a little trouble getting it to be 16.6 exactly. But 16.6 would be the time of one cycle. If you take 1 divided by 60, you'll get 16.6 milliseconds, and that is the time of one cycle. And remember that in AC, in one cycle, the voltage will go, or half the cycle it goes positive, half the cycle it goes negative. Does this 60 times per second. Okay, in this particular presentation we looked at sine wave characteristics. We looked at the various points of the sine wave as is being generated by the rotating coil. We also looked at the simulation. You might want to note that URL if you want to go there and do that on your own. We looked at the generation of rectangular wave shapes. And we looked at a battery, 2 batteries that could generate a rectangular wave, which is functionally this AC. We wouldn't usually generate it this way, but this was a way of introducing alternating current.